Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AMIR SYAFIQ bin Muhammad JAMIL. I will explain about simulation part 1. So, this is the result of the system. The system is run for 2 seconds. The upper graph represents speed in radian per second. The middle graph represents the torque of the motor. The bottom graph represents the armature current. The speed is around 1000 radian per second. The torque is very low in value because the torque load is not given. The torque load is equal to 0, so the armature current is 0. Then I set the torque load to the 1. So this is the result when there is a torque load, which is it shows the graph result when the torque load I set it to 1. And this is the board diagram that I get. That's all. Thank you.
I'm going to explain for part 2. So part 2, we change the value of inertia to power -4 and friction to 0.01. So firstly, we run just like the usual, click scope to see the simulation result, and then moving on to see the result for both diagram for torque control and speed control. The value are the same, and then we change the inertia to the new inertial value and same as friction. Make sure the port have been chosen so that the result showing for the board diagram. So this one is for torque control and then speed control. And then you can run and see the result for speed control for board diagram. And then we have to redesign the simulink so that we can have better situation and better than previous and part 1. So I changed the value of KIW and KPW by using the formula given in notes, so that we can gain a better result from before. And this is the simulation result. And then for the speed control, so this is the result for board diagram.
Hi, my name is IZZAH AFIQAH and I will explain about the simulation of part 3. For this final circuit, all the parameters are at its original values as shown in figure. Motor is operated to run at constant speed of 1000 rpm for 2 seconds. In the midst of operation, a load disturbance 5 Nm is given to the motor. Then we run the simulation, and the result, as we can see, the speed drop after 2 seconds and rise slowly to original speed of 1000 rpm. Next, for the second circuit, control parameters are then redesigned to improve situation. New parameters are changed as shown in figure. The motor is again operated to run at constant speed at 1000 rpm for 2 seconds, and a load disturbance of 5 Nm is given to the motor in the mid of operation. From the graph, we obtain that the speed of the motor only drops slightly. The speed rises back to the original speed and the torque remains same. For board load simulation for torque, we ran the simulation and got the result as shown. For the torque, we don't have to redesign the controller because the result remain unchanged. Next, we move to board plot simulation for speed. This is circuit for original parameters. When we run the simulation, we will get board plot diagram like this. The results have been discussed in report. Then we redesign the control parameter. We change Ki, Kp, and J value of the transfer function. When we run simulation, we will get the board plot simulation diagram like this.
In part 4, we need to change the value for the load disturbance. We also need to change the value of K1 until we got the max torque. Before that, we should run the simulation with K1 is 0.1 as the initial value. So, this is our result that we got for initial value. After that, we need to try and erase the value of K1 until we get the simulation result for speed, torque, and current like this question once. So we set up it for 0.3, and then this is our result. Our max torque reached the 1000 value, and the maximum load performance is not capable in order to increase. So this is simulation result are recorded.